module about networking and telecommunication. So this is equivalent to the chapter 5 of our open textbook. And it is a very important chapter again because it's very much relevant to what we're doing every day. Without networking, telecommunication, even web, almost impossible to do this kind of remote education. So uh, it's important. However, we don't have to know all that, right? I mean, as a user and the user, you don't have to know all that. But this is the course that trying to at least understand how it works, so that we have some understanding of them. And at the same time, it's I think is very noble thing as a business major. So I'm going to give you some introduction to networking and telecommunication. And but starting from the brief history, usually started with say 1950s. Most of this technology, including internet and networking technology, initiated by U.S. Department of Defense. They're still doing a lot of project, as you can imagine. They do a lot of AI related lately, including robotics and other technology they can use in military, especially. So 50s and 60s, they invested a lot of funds and time and efforts to develop network technology so that they can collaborate among those remote uh, military bases or military capabilities. So that's how they started, and the names are kind of interesting, like DARPA, ARPA, those coming from those defense perspectives. So it's always related to uh, military or Department of Defense. And 60s and 70s are more geared toward actual non-military technology, so that public can use it. Like late 60s, and those campuses, those engineers come up with what they call ARPANET. So they're trying to make a networking through those universities in the Western Coast, starting from UC campuses and Stanford and I believe University of Utah as well. So they tested those networking facilities and trying to collaborate. And I'm not sure how much they did it because the records are not much of. I mean, doesn't show too much of evidence the telecommunication was successful. But one thing they did was they some of those students trying to take advantage of this facility so that they can trade some marijuana stuff. Not sure how much was involved, but that was kind of story they uh, they told. Uh, that's late 60s and going through 70s. Then there comes the internet and World Wide Web. Actually, those two different things. We're going to talk about World Wide Web more details in next chapter, but it's more of internet and telecommunication technology that we're going to talk about. And here there's the terms they laid out right here. Those terms are more technical because it's involved those technology that they have to develop to make this networking works. So they have to use those terms. So we're going to take a look at those terms as well as some of those fundamental technology for telecommunication. So I'm going to go back to module 7 and there you go, TCP IP protocol. That's something I was looking at. TCP IP protocol. That's the current internet technology that we are using to exchange our data going through this network. And there are multiple protocol. Protocol here means technology, or you can say a particular set of big program, you can say. I mean, if you want to just materialize, because when you say protocol, it's more of conceptual thing and more of rules and regulations, but you have to implement. So that's what comes down to, thousands of lines of those codes that actually implemented uh, from the protocol. So let's take a look. So the idea is OSA model. That's more conceptual idea started like 60s and 70s. And TCP/IP protocol developed 80s and 90s finally applied to every facilities, telecommunication facilities we are using these days. When it comes down to the end users like you and me, TCP/IP protocols are installed on every machine, especially on operating systems, Windows or Mac, any kind of operating system. They have these TCP/IP protocols are embedded so that they can communicate through networking. So I'm going to skip uh, some of those pages are not really relevant. But it comes down to this 7 layers, what they call. So the idea was they trying to show any of those data transmission in 7 layers. So this again is conceptual framework they developed in the 70s. So that's top, that's more equivalent to the end users. End users are basically working on web, email, chatting, those application layer at the top. And if the layers goes down to all the way to bottom, there's more of physical transmission of data occur. So between those 7 and 1, you have all those conceptual idea of how you're gonna deal with this data and how you're gonna what you're gonna attach to the data so that you can send all necessary information to the other side. So that's all about those layer 6 to 2. And again, when started at the top, you got your content of email, for example, then presentation layer, so that how you're gonna interpret whether it is any kind of different language or any types of different protocol of that particular application they're using. So they have to differentiate. And session layer, they're trying to open up session to the other side so that they keep sending those signal. And so they want to maintain those session between two nodes, what we call. And transport layer makes sure that your data packet has been delivered the other side. So keep checking. So this layer always keep checking whether your message, in this case our email, has been delivered. If there's confirmation coming from the other side, then you're good. Then you're moving down to next layer. Otherwise, transport layer recognize there's no response from the other side, they'll send it again. So this is very important layer that making sure that your data is delivered. And network layer is more responsible for IP addresses and more of finding route. So basically network layer attach your IP address and as well as the receiver's address to see, I mean, to deliver your data communication. So it's all about uh, internet address. Data link layer has a couple of responsibility, making sure that your data is all uh, intact in terms of data integrity. So making sure data is checked well, as well as you're going to attach MAC address. MAC here means not like a Apple's MAC, as that stand for the network address, MAC address, MAC address. It's very unique to each computer or each device because each device comes with this MAC, unique MAC address. It's a little different from IP, but it's very unique to your device, very unique to your laptop, unique to your PC. So there's no repeated, MAC address. Will be attached here. Then finally at the bottom, all this data packet are embedded, what we call encapsulated into one packet, so that the packet will deliver through the networking, possibly going through so many different routers and switches to get to the destination. So that's basically how these 7 layers are working toward uh, the networking so that your data are delivered to the other side. Okay, to recap those 7 layers and TCP/IP. Again, remember the 7 layers are conceptual model. TCP/IP is the actual protocol they have developed and implemented into Windows and all those operating systems. And some of those 7 layers are embedded into TCP/IP and make it kind of merged one way or the other. So have it application transport network data link physical. So it's 7 layer becoming like a five of them. And each layer in TCP/IP has this function. And top layer, which is application layer, is more processing your application, just like initiating email, for example, again. And to do that, you need to have a sender's address to send your email, right? IP address specifically, and your address so that receiver knows that's you send the email. So that's how it started. Then comes down to the next layer containing UDP and TCP. UDP stands for User Datagram Protocol. It's more of protocol or uh, technology to send multimedia stuff like audio, video, streaming, those things, because it's faster and does it's not really complicated. Because TCP is more complicated, error checking, constant, checking of your delivery. So the UDP is simpler and quicker, so it's preferred by streaming or multimedia processing. TCP is just otherwise because its main things again whether the data packet has an error or the data has delivered. So it's always worried about your data, right? Just like your parents. So TCP is quite different from UDP. But anyway, in this layer, port address is recognized. Okay, up there was a receiver's IP address typically. Up over here, uh, actually, I should say it's not IP address. IP address is recognized here, but right there, uh, when you initiate, they look for other databases of receivers so that uh, a particular device will tell you what's the IP address, what's the receiver's address. So it's not you recognize right away, but you request a service to database. That's what we call DNS or other domain service. That's domain server network DNS. But anyway, that's what happens. So that's again comes down to port address. Port address you need to have a actual address. It's not like a computer port, physical port. This is more logical port. So port number must be identified so that the other side will use the same port. Let's say it's port number 80, right? Let's say you are sending web requests. Maybe you are sending not not email this time, probably you click to one of those web form, like click submit, then that means the port number will be activated, which is 80. Port number 80 must be open in the other side so that they have a matching telecommunication is occur by the same layer. Okay, so that's why port number is very important. Port number theoretically can be hundreds of them. Again, because this is not physical port, it's a more logical port so that you have some kind of tunnel established between you and the receiver. IP layer is, again, this is more IP address issue and routing issues. Okay, so you don't have to worry about how you're gonna send it and where, but there are thousands of other routers and other network will find the better way to deliver your message. But here you just identify the IP address. Then data link layer is just between data link and physical layer. Physical address will be addressed. Physical address here I mean MAC address that I was talking about, and this will occur at the bottom. So that's right before you open IP address when you receive. But when you send, that's after IP address recognized. So all depending on how you whether send it or receive it, the order might be different. But MAC address is not recognized until the data is received in network, local area network. Because MAC address is not really known to everybody. That's because it's very unique. Like I said, MAC address is just like your social security number. You're born with it, for example. Or you can have multiple for some cases. But again, MAC address is not known to everybody else, but only known within your network. So this is the last ID that you will find out when the message is delivered. So as you can see, all those addresses or those data must be identified to deliver your email or whatever message you're trying to transport. So it's kind of giving you an idea of how TCP/IP works. And again, once again, summarize. I have probably too many tables trying to summarize over and over, but hopefully it makes sense. And if you have any questions and comments, and let me know. Thanks a lot.